So here we're going to start off with how to rationalize radicals. Well, before we start, let's talk about the word rationalize. The word rationalize means to get rid of. So we're going to get rid of the radical whenever we have an expression. So if we look at topics number 1 to 7 in your worksheet. So here in your worksheet, numbers 1 to 7, you have all these radicals in terms of fractions. And when we talk about fractions, we think of it as division, right? Because fractions are like division. So again, we've learned how to add, subtract, and multiply fractions, but how do you divide fractions? Well, we're not going to divide the fractions. We're going to rationalize the denominator of these fractions. So notice the words rationalize the denominator. So in other words, we want to get rid of the radical in the denominator of a fraction. Notice that all of these instructions or directions says rationalize the denominator. If it says rationalize the numerator, then of course you're going to want to get rid of the radical in the numerator. But in this class for algebra, we're only rationalizing the denominator. But in calculus and maybe other topics, you might be asked to rationalize the numerator. So the question is, how do you get rid of this? How do we get rid of radicals in a fraction? So the first thing we want to, before we get into that, the first thing I want to know is a reminder of a few things. If I had square root of 3 times square root of 3, we're going to get square root of 9, right? 3 times 3 is 9. Well, 9, the square root of 9 is simply just 3. Let's look at another one. If I get square root of 4 times square root of 4, I get the square root of 16. And what's the square root of 16? 4. Notice the pattern here. Square root of 3 times square root of 3 just gives you 3. Square root of 4 times square root of 4 just gives you 4. So if I ask you what's the square root of 89 times the square root of 89, instead of multiplying these two to get some big number and then simplifying, notice that the shortcut is that when you multiply a radical by itself, in this case, then you end up just getting the radicand, the number inside the radical. So square root of 3 times square root of 3 is just 3. Square root of 4 times square root of 4 is just 4. Square root of 89 times square root of 89 is just 89. Same thing with if you have letters. If I have square root of x times square root of x, the answer is just x, right? And this is because of what a radical is. What a radical is asking us, what number do you multiply twice to give you the number 9? Well, the things that you're multiplying twice is the radicand inside. So square root of 3 is equal to 3. So just a reminder of that. So another way of writing this then is, if I'm doing square root of x times square root of x is equal to x, I could write this as square root of x. If I squared this, that'll just give me x, right? If I put the square root of 27 and I squared it, I just get 27. So this is another way of writing this here. Multiplying by itself, or you can say you square it. So this is the big kahuna idea of how do we get rid of radicals in a fraction. So let's take a look at number 1. So example number 1, I have the square root of 13 over the square root of 52. So square root of 13 over square root of 52. So I noticed that the direction, basically what I want to do is I want to get rid of the radical in the denominator. So if I want to get rid of the radical in the denominator, I am going to multiply. I want to get rid of this radical. How do I get rid of square root with a 52 in it? I basically want this to equal just 52. So I don't want the radical in there. Well, knowing what we know here, what do we need to multiply by to get 52 sitting by itself without a radical? We multiply it by itself. So square root of 52, if I multiply it by square root of 52, similar to what I just did here, then the answer is just 52 without the radical. That's pretty cool because now I have no more radicals in the denominator, and that's called rationalizing the denominator. And what we know with fraction, and with mathematics in general, is whatever you do once on the bottom, you must do the top. So it must be balanced, right? So since I multiplied by square root of 52 on bottom, I also must multiply by square root of 52 on top. Now, what is square root of 13 times square root of 52? Well, I don't have a calculator on hand, so I'm just going to do this the old-fashioned way. I get 676. That's a really big number. So 600, let me check my answer. 6, 2, 15, 6, 6, 7, 6. That's right. So here I get this huge fraction. And what we know with big fractions like this is that we always want to make sure that we simplify it. All right, and before I keep going on, let me ask you, what did I just do wrong here? I put 52, the root, but multiply together I get 52. 13 times 52 plus 676. What am I missing? Oh, that's right. I'm missing the square root. So make sure when you're multiplying radicals, you have that radical over that. So even though the radical in the denominator disappeared because of this here, the top 13 times 52, remember there's always a square root on top. So square root of 676, if you actually just plug that into your calculator, 676, you take the square root of that, you end up getting 26 over 52. And 26 over 52, remember we always want to simplify our fractions whenever we answer it. They're both divisible by 26, so we end up getting 1 divided by 2, or 1/2. So the answer for number 1 is 1/2. Now let's take a look at something. Let's make it a little bit more complicated. Let's look at example 2. So example 2 here, I have 5 over the square root of 3. Again, the direction is to rationalize the denominator. So I want to get rid of the radical in the denominator. So to do that, I'm going to multiply it by itself, right? So if you multiply square root of 3 by itself, you end up getting square root of 3 times square root of 3 is just 3, as we did up here, right? Square root of 3 times square root of 3 is actually square root of 9, but if you simplify, that's just 3. But you could just shortcut it by saying if you multiply a radical by itself, you just end up getting the radicand, the 3. So here's that, and remember whatever you do bottom, you do to the top. So 5 times square root of 3 is not square root of 15. So be careful, this is not square root of 15. I see students do that a lot. Remember that when we're dealing with multiplying radicals, the numbers on the outside of the radical stays outside, and the numbers inside the radical stays inside. So here we have 5 root 3 over 3. And you might be wondering, well, there's a root 3 here. Do I need to get rid of the radical? And the answer is no. It's okay to have a radical in the numerator where it just asks to rationalize the denominator. So therefore, this becomes the final answer for example 2. All right, now let's take a look at example 3. So again, each one's going to get a tiny bit harder. So here in example 3, I'm going to have the square root of 7 over 5. So when you look at this, you might be saying, well, I don't see a radical in the denominator. Well, actually, there is a radical in the denominator because this radical is over the whole fraction. This can be rewritten as radical 7 over radical 5. So this is one of the rules of radicals. So I'll write it as on the side here that notes if you have a fraction under a big radical, the radical is applied to both the numerator and the denominator. So just be aware of that. So therefore, when you have a fraction under a radical, you can break up the radical from the top and the bottom. And now that you have it in this form, we're going to do what we did earlier, where I want to rationalize the denominator. So to get rid of the square root of 5, I'm going to multiply it by itself. And again, when I multiply it by itself, root 5 times root 5 just gives me 5. Similarly, whatever you do on bottom, you do on top. So on top here, square root of 7 times square root of 5, well, because they're both underneath a radical, I can multiply these together, and I get square root of 35. Right? And can I simplify square root of 35? The answer is no, because the only thing you could simplify 35, if you break it down to 7 times 5 is 35. Square root of 7 times square root of 5 cannot be simplified anymore, so that is what it is. And that becomes your final answer for example 3. Now let's go ahead and throw in some variables or some letters in this problem. So example 4 here, I'm going to have square root of 5 over square root of 3z. So square root of 5 over square root of 3z. So to do this problem, just because it's a variable, don't be scared. It's the same idea. So I'm going to multiply the denominator by square root of 3z. So when I do that, this times that will just give me the radicand. Again, the radicand is just what's inside 3z. When you multiply a radical by itself, you just get the inside. And again, whatever you do bottom, you do to the top. All right, so when I do that, this times that, since they're both underneath the radical, I can multiply them together. So here I get square root of 15z all underneath the radical. And you might be tempted to, oh, can I cancel anything out? And the answer is no, because square root of 15 and 3 are, this is underneath a radical and this is not underneath a radical. You can't cancel them out. It's not saying 15 divided by 3 and I could cancel things out. Remember, it's square root of 15 and divided by the 3. So therefore, nothing can be canceled out. So please don't cancel things out. And this becomes your final answer for example 4. All right, so now we're going to make it a little bit harder.